So in this video, I'm going to try and do a basic floor flatness survey, generate a report on it. And I'm also going to use a new feature, which I haven't demonstrated yet, which is our Python API. So I'm going to use the Python API to export the data in such a way that I can create a kind of graph, bar graph of how the data deviates from a given level. So to do that, I'm first of all going to turn off what I don't need. So I've already gone through the process of just classifying the ground, or rather the floor. So I'm going to turn off what I don't want and turn on the floor data. Okay, so having done that, my first step then is to create a grid of levels. And what I'm going to do is I'm going to set the height mode to average, because there might be a little bit of noise in this data. So what we'll try and do is average that out a little bit. A grid set to 250 mil. And if it can't find a level exactly where it's looking for one, it's going to go looking at a maximum of 25 and around that. So normally you would untick creators points because you want to create a surface. But because this data is so small and I want to just play with it as a normal DTM, I'm going to use creators points. So I will get points rather than an actual surface. Aligned spacing just means the origin will be perfectly aligned to 0, 0 and show through cloud so we can see the data. So if I hit preview grid, n4ce extracts the data and interpolates it where necessary. Okay, so there's all our levels. So if I quickly just turn off the point cloud, okay, there's our data points. So if I turn it back on, obviously we can see you've only got points where it could actually get some data. Okay, you can't fill in the holes. And what we're going to do with this data now is we're going to essentially push it through and create survey points with those. So I'm going to hit create grid, and it's just going to push those straight away back into the model. Right, so if I zoom extend to the model, here we go. Now the points at the moment, if you hover over them, if you've got hovering turned on the side here, tooltips, okay, you can see it says code none. It's got no code. If I look at it in the spreadsheet view, that's how it looks. Okay, that's not a problem. I don't want them coded at the moment. What I want at the moment is a DTM. So I go DTM, create normal. Okay, so now I have a ground model. If I go to contours and go to the contour defaults, they're probably set up for more of a topo situation at the moment. So rather than have an interval of say 200 mil, let's try an interval of 2 mil. And just so I can see them on a white background, let's just have them, so we say, in magenta. Okay, we can see our contours. Right, if I just turn off the model, turn off the points, there you go. All right, so we might have a few extraneous points that we need to sort out. So turn the markers back on, go to points, delete, indicate in element mode, and I'm just going to click that and play that one up. There'll be a few more in places, maybe that one there. Okay. Right, so when you're happy, you tidy up the extraneous points. What we need to do is you need to make these contours sort of mean something. By that, I mean make the contours show us what's high and what's low. So if I hover over these points here, they all seem to have a height of about minus 0.455. So if I add 0.455 to all of these, my contours then become essentially contours above and below 0. All right, so above and below a datum of some sort. So if I go to points, I'm going to go to move, I'm going to go to raise, and I'm just going to change my picture to a rectangle for obvious reasons, and I'll add 0.455. Okay, so now I have a blue line in here, which will be my 0, and I have heights around 0, which is what I want. Okay, if I were to now turn on the shading, I see something like that. And obviously the shading at the moment is more intended for a topo survey, so the shading interval is probably a bit large. So if I were to go to the DTM menu, to DTMs, if I set that to say 2 instead, I'd obviously get a different graduation. Okay, but it's still not obvious what's high and what's low. So let's modify that again. So the DTMs, I'm going to user scheme, go to intervals, and I'll add a keyword min, because intervals understands what the min value is. Okay, so let's say that we're targeting plus or minus 2 mil. So if I go minus 0.02, and then put in positive 2 mil, and then the keyword max. And we'll have anything, let's say low in red, and anything that's around 0, so plus or minus 2 mil white, and then the maximum, let's have that in, say, blue. So we're going to go from red to white to blue. Press OK. Press OK. That's what we get. Okay. So you can see if I hover over that data there, that's negative, so it's red. Up here, it's positive, so it's blue, and everything in between. There's a shade of that. Turn off the markers. There we go. Maybe we want a grid of levels over that to make it more human readable. So to do that, I'm going to create a grid over this surface. So I've got models, point grid. Let's call this one grid for argument's sake. And we'll have a 2-meter grid using the code SL. And we will interpolate over our school model. So here we have our grid model, coded SL. Right, now these at the moment are just in, obviously, meters plotting the height. So I'm going to switch to a different code rather than SL, which has already been set up. So codes, here it is. I've created it as FL. So in this situation, rather than plot the height, okay, the height's turned off, what we're actually going to do is we're going to enable the text. Okay, and this is a text macro. If you're not familiar with them, they're very powerful. They have a lot of help on our online help portal. Here is our help portal. This is where a lot of our online help is. And if you were to search text macro, there they are. Okay, so here's all the help based on that. There's all sorts of items you can extract if you need to. Today, we're going to extract the height, so PZ, and we're going to do to 0 decimal places, hence the .0, curly brackets, tell it to do some maths, times 1,000, put millimeters on the end. Okay, so if I cancel all of that, and I just select these points, I choose recode, to FL, then look at the model, and just move it, it'll update, there you go. So we now have our heights, rather than in meters, they are being presented in millimeters. And I can do Alt B for backcloth, put it in that model. Okay, so there we have the first stage of the deliverable. We have ourselves some spot levels over the site, and we have a shading diagram to show us what some of those spot levels mean. So we could do a tighter grid if we needed it. What I thought would be useful is if we use the Python API to create a graph of, shall we say, the percentages, how close the data is to these values, say how much of it is in, say, plus or minus 2 mil, how much of it is negative 2 mil, how much of it is positive 2 mil, so on, so on, so on. So to do that, we're going to make use of the Python API. Okay, so for those who aren't aware, Python is a very powerful scripting language. It's very much used in the machine learning side of industry. But today, we're going to use it to essentially connect n4ce's model to an Excel spreadsheet. Okay, so to do that initially, what I'm going to do is I'm going to go to run script. I'll explain how this works in a second. Here's the script I've already prepared. Press open. Now it's asking me where I want to output the spreadsheet. So it's asking me what file name I want to use now. So we'll just call this one floor flatness checks. So okay, well, I press save. Okay, it's done. All right, so let's go and have a look at that. Okay, so here's the spreadsheet it just created. So I'm going to double click that. Okay, so you can see at the moment we have the results, but the data is actually to the nearest 5 millimeter. Right. So what we're going to do is we're now going to dive into the code and see about changing that. So I'll close down. Let's save it. Okay, now to edit the Python code, I'm using an application called VS Code. I'm not going to describe the ins and outs of Python. There's plenty of tutorials on YouTube that goes through the ins and outs of Python and the basics of how you get to grips with Python, but they pretty much all use VS Code, which is a free development environment, which you can just download and install. So n4ce now comes shipped with its own build of Python. There's lots and lots of builds of Python, but n4ce comes shipped with its own, so you don't have to download Python and install Python. All you need to do is download and install VS Code or your preferred development environment. So let's look at the code. I'm not going to explain every single line. I will explain the parts of it that pertain to n4ce. Okay, so So here you can see at the top, we basically reference the n4ce API here, top. So what we're going to do is later on, down here, we are going to iterate through the database. So the database line is here. So basically we say get the current database. There's other ways of getting different databases. You can use the name if you want to. All right, once you've got our database down here, we're going to iterate through, loop through each point of the database. Now here is my intervals. At the moment, it's set to 5 millimeters. When I set my contours up and my height shading up, I actually had it set to 2 mil, right? So let's change that to 2. Now we're going to iterate through each point of the database. What we're basically going to do is we're going to round it. We're going to figure out what that nearest height interval is by rounding it. And then we're going to use a dictionary. And a dictionary is essentially a way of storing information with a unique key and then some data. So in this situation, the key is the banding, and then the value it's storing is the number of items that are in that particular band. All right, so if it doesn't exist, it creates it, initializes it to 1. If it does exist, it then increments it by 1. So we're basically adding data to various pots depending on which band that height exists in. And then we convert those counts to a percentage once we know how many points there are in total. The rest of this is all Excel code. I'm not going to go through that. We're using the OpenPyXL toolkit for this. There's lots of tutorials online for this as well. But all the code you need to set up the spreadsheet, to color in the data, to format it, to make the chart, it's all in here. All right. And then at the very end, we export the data to a named file. So I'm going to save this now, and we'll give it a run. So back to n4ce, run script, run that, open. Make sure Excel isn't running, or you'll get an error basically saying you can't update the file because it's open already. Save, basic yes. Launch the file. And you see we now have more bands because we changed the interval. Now, one last thing I'm going to do is I'm going to turn this into a picture and then drop it onto a drawing which shows the layout of the data and the heights and so on. So, and the last thing I'm going to do is I'm just going to very quickly create a drawing which has got the data on it and this graph. So to do that, I'm going to turn the graph, save as picture. Just for now, I'll drop it in the same place. That's my script. It's on for flatness. Leave with the extension off, and it'll save it as a PNG. So now back into n4ce, get to go to the grid model. What I'll do now is I'm going to Tools, and I'm going to use a predefined drawing layout, which you can obviously import from other DWG files, but I'm just going to use this one I've already got set up. So it's a bit of a Mickey Mouse one. I'm not sure what scale is going to work, so let's try 1 to 100 initially. I think 1 to 100 will do us just fine, so let's position it there. Let's call that DWG1 for the time being. Right click. And now double click DWG1. That's our sheet. And now I've got some room here for my image. So I've got Tools, place image. Here it is. Open, click, and drag. There we go. And then if I want to just move it, click it, move it over a little bit. There we go. Right, obviously you need to fill in the boxes, and this is obviously just literally just to give you an idea of what's possible. What do we need to do now? If we want to spit that out or export it as a PDF, I can just go Adobe PDF. Just copy that. Set the defaults. And here it is in Edge, viewing the PDF. Here's the file. As you can see, we've got our floor data, we've got our graph, and we've got the rest of the layout. And that completes this video.